Henry, hi, and thank you so much for joining me here on Faces of Digital Health to discuss where we currently are in digital health when it comes to voice biomarkers. In the last few years, ambient technology for speech recognition and note-taking has really taken off in healthcare, but there's many other applications that have been in development for years. So we'll discuss to which extent are these technologies already used for disease detection, prevention, wellness, and more. So welcome, and I look forward to this discussion.
Thank you very much. It's very nice to be here with you today. Thank you.
So let's start with a very general question that's going to prepare us for the broader discussion, and that is, what is the potential versus the current reality when it comes to voice biomarker? Like healthcare innovation is full of ideas on what else we could measure and correlate with medical conditions. We keep searching for new biomarkers that could tell us something and enable us new ways of diagnosing things. And so how powerful is voice already? And what do we wish we could decipher from it, but we don't really have the clinical proof for that just yet?
Sure. A little bit of a historic perspective. Canary was founded by myself and Jeff Adams. We've known each other for 40 years. I was at the National Institutes of Health, research in neurological diseases. Jeff was at the NSAR spy group in the US, building mathematical models to de-encrypt spy messages during the Cold War 40 years ago. Foundationally, that's the foundation of what we do with speech and language, really. He went on to build natural language processing tools, working with a gentleman named Ray Kurzweil. He led the team to build Dragon Naturally Speaking, the very first speech detect text clinical commercially available product. He did the same thing for legal dictation. He also led the team to build the Amazon Echo. Amazon simply bought the company Jeff was in when they wanted to build the Echo product, far-field speech. For a very long time, for the last 25, 30 years, very, very intelligent people utilized those tools to analyze the spoken word. And there was modest success. So if you're analyzing the spoken word, a textual representation of that, doing mathematical evaluation of what words people speak in whatever language they're speaking and how that may correlate to their disease, you can create useful correlations, but in 25 years, there were no clinical products produced. And part of the reason was that the data, the density of the information, if you're analyzing words that you speak, gaps in words, the size of words, the syllable of words, the data size, the data set itself is measured in a few hundred data elements. The actual primary data layer that allows the articulatory system to create that language is measured in millions of data elements. How the central nervous system controls my vocal cords, for instance, or the movement of my tongue, how I expire in coordination with everything else I'm doing to actually form words and communicate words. In every language on the planet, it's the same data stream. It's the primary level data stream. But for 25 years, people didn't focus on that. They focused on words that were being spoken. There was some modest advancements by MIT in identifying Agatha Christie's cognitive decline with Alzheimer's disease. Very, very interesting work. But it was 40 years of Agatha Christie's novels. In a practical sense, most of us don't have 40 years of novels to take to our clinical team to have them evaluated. So there wasn't any practical application in a clinical sense for doing that. So 9 years ago, when we started Canary Speech, we kind of turned the whole thing upside down and said, we're not going to pay attention to that historic work. We're not going to measure words. We're not going to pay attention to words. We're going to pay attention to the primary data layer. The signals coming from the central nervous system that drive self-consciously how the vocal cords are functioning in order to create language. And as we talk to one another, you get a sense that I'm excited about the work we do. I don't have to say to you, I'm excited about the work we do. You know it. And it's that same sense that clinical team members have. We call it intuition, but that sense that when a person says, I'm doing fine, and a mother knows their daughter's not doing fine, or a doctor knows their patient isn't. It's not the spoken words. There's some other information that we were capturing and gathering. And in a bagel shop 9 years ago, while Jeff and I spoke about this, I asked him, how are we doing that? Because we have a machine learning tool that does that. Mm-hmm. And doctors and clinical teams do it every day, and parents do it every day, and we do it on the telephone even. We don't have to see the person's face to know that it's a good day or a bad day. I asked him, how are we doing that? And he said, I don't know for sure. I don't know. And I said, because if we created a product that could objectively measure that in the hands of a patient or in the hands of a clinical team member, regardless of whose hand it was in, it was going to analyze that data stream the same way. That's a very useful tool, It validates what I'm thinking. It gives me another independent source of information, allowing me to make a more accurate diagnosis. And you could do that remotely. It wouldn't matter where a person was in the world. A doctor could do that on a telephone, or on a video conference. So it could extend the reach of healthcare to anyone, regardless of where they were born. And that was exciting in the bagel shop, and we started pursuing that. So today, we actually analyze about 12 different diseases that have all been built with clinical teams in different parts of the world. Some in the US, some in Japan, some in Europe. We're working on Arabic and with Cleveland Clinic in Abu Dhabi. We're doing work in Holland right now, validating in Dutch mild cognitive impairment and Alzheimer's disease. But we decided in the bagel shop this would be a tool for clinicians and clinical teams. So we built the thing all within the healthcare sphere, all within that environment. There's a different set of requirements. There's a different set of validations. There's a different understanding about data security and patient integrity, and the efficacy of what you do is different if you decide I'm building it there. I'm not building a Facebook product, which is very valuable to certain people. I'm building a product that is going to interact with the patient and the doctor. And the other concept was don't intrude in that. Don't interfere with that. So that meant listening. Be a listener. And so that was kind of conceptually where we started.
Yeah. So tell me, I'm going to ask what you asked your co-founder or friend. So how exactly are you doing that? Do you need to compare a person's speech over time? As you mentioned, for Agatha Christie, 40 years of books, and you could see how maybe her brain patterns or her thinking was changing. Like, how do you do that? An individual, like, do you need a lot of data from the person? And also, yeah, we'll dive into more technical details later on.
Sure. So we analyze approximately 45 seconds of conversational speech in an ambient mode, in a mode like you and I are talking right now. You could be analyzing where my anxiety, depression levels are, whether or not I have cognitive implications or disease, whether or not I have Huntington's or Parkinson's or MS. You could be measuring all of that while I'm talking. What we're able to do now, utilizing in AI and the computational capabilities of our web and other services in a high trust environment, ISO certified capability, and audited. What we do is we listen to the conversation between two individuals, a clinical team member and a patient. And when the patient is speaking, we're picking up 8 seconds here and 12 seconds there and 10 seconds here until we get to about 45 seconds. That represents about 13 million data elements for us. We look at 2,590 different features in the human voice every 10 milliseconds.
Okay.
And it's actually a 25 millisecond window with a 10 millisecond slide. So functionally or effectively 10 milliseconds.
Let's stop there for a second. So how did you define all those nuances? Because from the human perspective, I can, especially if I've known you for a long time, I can see what kind of mood you're in. I can see if you're excited, if you're sad, if you like someone, if you're annoyed. But how do you define so many parameters, and what are they?
Yeah. So you just stated what I did in the bagel shop with Jeff. I said to Jeff, and he's known my family for 40 years. And I said to Jeff, when Caitlin, my oldest daughter, would come home from school after soccer practice and she's walking across the room, I could tell from her gait whether it was a good day or a bad day. When she turned and looked at me, I get all kinds of more information. And then as a parent and a parent-child relationship, when I asked her, how was your day? You already know what her answer was. It was fine. And she would keep going, and I would go, no, time out, come back. Because I know it's not fine, and that's what we see in people. And those are the physical cues that we're reading. And then as they're speaking to us, we get more information. I said, Jeff, my daughter's, and he knew this already, but my daughter's married now. She had her first child 9 years ago. She now has 2 boys. She doesn't live with me. Not my best moment. I'd still have her here, but that's not life. That's not what we do as parents.
Yeah.
But I said, when I call her, and it's irritatingly accurate, and it has nothing to do with the words she's speaking, and I can't see the physical cues anymore. I know if she's having a good day or a bad day. I know if she's happy or she's sad or she's excited or she's upset. I know all of those things. And I say to her, what's up, honey? So I said, that's what doctors and nurses and clinical teams do all the time. We all do that. That's how we got there. Now you ask me, where do all these elements come from that we look at? 35 years ago, when Jeff was developing NLP, the textual representation from voice, many of those elements already existed. They discovered them. The vibrational characteristics of the vocal cords, we call it jitter or shimmer or other things. Everybody loves to attach words, particularly if you're in an academic setting, you create new words because it creates your own language and it makes some specialty, but they're all the characteristics of the respiratory sounds, the sounds of our mouth and of our chambers, of the vibrational characteristics of our vocal cords, and how fast those are changing and how quickly they recover, which would be first or second order derivatives of those things. All of those, most of those existed. There were 2,545 identified ones when we started. We have 2,590 now. So the vast majority of them were there. They were available.
But that's still so much
information.
Yeah, 2,590.
Yes.
That's I just I have a hard time getting my head around how do you get to that number? What do you do? Do you just do you record the voice? Did you record 100 patients and then doctors were listening and were looking at how the voice looks like and then they said, oh, here I can see that, there I can see that. How did you map out the
Yeah, yeah, intuitively.
2590, yeah.
Yeah, you're just so smart. So imagine that we have, there are, in the industry, over these last 35 years, we've created the ability to extract these features from voice. So we can extract these features from the voice. We actually use 5 different types of feature extraction tools. We stack them. How they're stacked changes things up a bit. So we had to do a lot of experiments. Try it this way, try it that way. We associate ourselves with clinical teams all over the world, like Harvard Beth Israel and Intermountain Healthcare and Hackensack Meridian and in NYU and Ulster Hospital in Belfast and telehospital and hospitals in Japan and in Saudi Arabia and other places. So we associate with clinical teams that are diagnosing patients. So if it's a neurological disease, it's a group of neurologists working side by side with us. We create a protocol, which is reviewed by what's called an IRB for human research. We create a mechanism by which during the interview that the doctor's having with the patient, we're capturing their audio, the patient's audio. And the doctors create a diagnosis of that patient for a particular disease, anxiety, depression, mild cognitive impairment, Huntington's disease, Parkinson's, MS, whatever it is. They create a diagnosis, that becomes a ground truth. That's a label. This individual, while they gave us their audio, was also diagnosed to have Parkinson's disease. We take that label, that Parkinson's label, which is complex. There are multiple different tests they've given them. All of that is digitized along with the features that we extracted in that 45 seconds, which represents 13 million features set. And then machine learning takes that information and it develops a correlation between the doctor's diagnosis and the patient's 13 million features.
Mm-hmm.
That
So
correlation. Go ahead.
what's the current accuracy of these diagnoses? Based on the amount of data that you're mentioning, I would assume it's high, but if it's high, my next question is, why is this then not the standard of practice in clinics to diagnose, especially given how long you've mentioned that this technology has been in development? We're used to seeing that it takes maybe 20 or 26 years, I think is the number, from a new piece of technology to become a standard of practice. But when it comes to using voice to diagnose Alzheimer's or other mental health conditions, it's not really the first thing you would think of as a diagnostic tool.
Sure. So the approach the first 25 years was using words, and word-based analysis was never very high in accuracy. Plus, every single language or different use of language within a country, going from the Northeast and of the U.S. to the South or to the Southwest, people use language differently. So a word-based approach was difficult to control for, and it didn't offer very large data sets. It was 1,000 words and gaps in syllables. We're now working with 13 million of them, 13 million different discrete, or 13 million data set with 2,590 discrete elements. A much, much different approach. So accuracy in progressive neurological diseases such as Huntington's, Parkinson's, Alzheimer's, those kind of things, accuracies are 98% plus. They're very, very, very accurate. And that's a clinical decision support tool, if you will. So a doctor looks at that, and they look at the other tests they're doing, and they look at the information from their expertise, and they put that myriad of information together to make a decision about the diagnosis of the patient. When you get to things like behavioral health, diagnosing behavioral health isn't as accurate. Anxiety ranges, doctors can range. So it's in the 80s in that case. The wonderful thing about a tool like this, everything I mentioned in that 45 seconds of capture that we do, all of them can be measured at the same time, or any one
Mm-hmm.
of them. You can pick like you do, from a list. I want to measure these 4 things. So you could look at a patient suffering from early stage cognitive decline, mild cognitive impairment, but you can also measure their depression, their fatigue, and their anxiety levels simultaneously. So a doctor looks at that, and that information is available to them in real time. One of the other questions you asked is something that we asked ourselves. We spent months coming up with it. You spent minutes coming up with it. But nonetheless, same question, which is how applicable is this across populations? Or do I need to watch a person over time, like they did with Agatha Christie? They actually looked at her novels across time. When you attach yourself to the primary data layer, which is directly connected to how the central nervous system creates language, our central nervous system is 99.999 the same. You and I were born in different parts of the world, but our central nervous systems and how we control our vocal cords is identical. So much so that I'm developing our models based on a group of individuals who have the same functional central nervous system controlling the motor functions that create speech. The articulatory system is nearly identical, regardless of what language you're speaking to.
Yeah.
It's a tool that's more practically applicable across populations. When I measure your anxiety, or I measured the anxiety of the initial test group, I didn't know anything about their yesterday. I didn't know what their history was. I was measuring that moment of time.
Mm-hmm.
And so we can measure longitudinally, and you can track an individual, which is very useful. But I can also measure what is present in the moment, which is so critical, because our genome can tell us what our susceptibility is for a future disease, but not whether or not we have that disease.
Yeah.
The same is true of an LLM. Large language models can tell us that we correlate with individuals who have certain diseases, but it's not telling the doctor that I do. It's telling the doctor that I have a subjective correlation with people who were previously diagnosed with something. What I'm telling the doctor is what is present in the moment when the
It's,
clinician is with them.
I still wonder to which extent, the diagnosis could potentially be wrong, because speech recognition is not a brain-computer interface that would measure, brain signals. When you said that, it's the way that, speech is created in the human body is the same over population. This kind of reminded me on the development of brain-computer interfaces for motor functions or for speech, which also do not need to be developed all over again in every language. But at the same time, if I think about the different cultures and how some people speak more quietly, some people have a lower voice, a higher voice. I'm wondering to which extent do you have to do configurations over cultures because different cultures express themselves differently, and maybe if somebody speaks slowly, that's gonna be an important biomarker because that person in the past was speaking fast, but then maybe you've got another person that's always speaking very slowly. And depending on how the model for recognition is coded, that might be misinterpreted. Am I making any sense?
No, you absolutely are. It's, again, a question we asked ourselves. And so there are many different things. We asked that question, and then that results in a pattern of development and a pattern of behavior and attitude towards efficacy that results in our taking certain actions. One is that we never deploy in a new language without validating, doing a similar clinical trial within those languages. The algorithm for mild cognitive impairment was first developed in Japanese. It's just where it happened to be. We brought that same algorithm back, and with our understanding of the features that created that algorithm, it gave us a head start, if you will. But we independently validated that in English and in Spanish and now in Dutch and Arabic and other languages. So every single time we do it, just like you would with any diagnostic piece of equipment, you don't put it on the floor and say, good luck. You put it on the floor and you validate its performance. You use certain standards. In our case, we're using standards. Those standards go back to the ground truth, which is the neurological team or the psychiatric team or the specialty team. So that's our set of ground truth standards. And then we validate it across them. The second thing we did was we asked ourselves the same question you did. Intuitively, you just asked what we had a group of very smart people doing. We said, well, we developed in the Northeast with a group of hospitals, we developed this particular test, analysis on a particular disease. Is there a difference in the population that resides in the southern states or in Hawaii or in Alaska? So we hired 3 separate CROs and we had them collect data from, in this case, all 50 states. And we then tested for the accuracy and efficacy of it in those states. And that not only gave us a definable, scientifically derived correlation of accuracy across different population groups, but it also helped us in training the noise characteristics, because this gave us a very broad reach for different types of noise. Machine learning can deal with that as long as you're building it into it. You could take artificial noise, which we do, and build artificial noise into it. It helps make the models more robust. But the characteristics of is a cultural difference in the South, where they speak slower than I grew up in the Northeast, softer, if you will, in the South. Is that going to change the perspective of how, say, a behavioral health model works? Or would that make it more likely for me to be perceived as having some cognitive illness because of cultural changes or differences? So those things can't be taken for granted. They needed to be evaluated. So we did that. Then for instance, the Spanish models have been developed in multiple South American countries and multiple Spanish-speaking populations. Spanish in America is a conglomerate of different Spanish, So could a Spanish model be developed that could be Guatemalan or Peruvian or Colombian and still work? You don't know that for sure until you actually do that. So that's why it took us 9 years of work. And, we're older. So we're, it wasn't like I was doing something else. I wasn't going to go play golf. I don't play golf. So we did that kind of thing. And the same thing is true of other languages. We take we take what we have learned in building in one language and we carry that to the new language, but then we do the same procedures. Now, it doesn't take us as long. The first models took us a year to develop. We add new languages with existing models in 6 weeks now. So we've gotten a little bit better at what we do, but it's still validated with a group of experts that create a ground truth. And then you compare the ground truth. There are other little things that we do, but we have a group of scientists that are international in their flavor and nature. I mean, German-born, Korean-born, Indian-born, American-born, educated in different parts of the world. That was intentional. We didn't just say, I don't know, Caltech is a great school, MIT is a great school, Carnegie Mellon is great at speech. We're going to go get a team of experts from Carnegie Mellon. When you're doing something that's never been done before, one of the mistakes is to try to do it with a narrow group because they have their own think. So we gathered a group of individuals that had life experiences that were very different, that learned from different PhD programs, that had different, we speak within the company, we have about 15 languages that we're fluent in. I'm only fluent in English, but our employees are fluent in multiple languages. They're linguistics, PhD level. machine learning PhD level. So we're not only blending different programs, we're blending different types of expertise in order to do something. But I think to do something that's never been done before, you got to be humble enough to pull in a team that's that diverse, you know?
Yeah, absolutely. Absolutely. It's, innovation happens when you try to do something that's never been done before or goes against everything that we currently believe. So I can completely understand that the need for diversity and just, getting people that have different points of view. So you prove your point. Given high accuracy that you mentioned that is possible when it comes to diagnostics through voice biomarkers, how well accepted is this in clinical practice so far, and why isn't it the first thing clinicians would think about when they're trying to assess your cognitive health?
Pioneers in the field, if you go back 25 years and things like that, pioneers in the field, and they started by analyzing the spoken word, which they adopted in a whole bunch of, it's so easy to look backwards. So I need to preface that first, because when it never had been done before, the things they were trying were good ways, good examples, even if they were, dead ends for them. So a lot of the early work was adopting the methods of speech pathology, because speech pathologists are excellent. When I was young, I had a number of things I couldn't say. And whenever I consciously think about it, I bump into little trouble. So like SHs and CHs and TCHs at the end of words, I had trouble saying that. And a speech pathologist helped me get to a more fluent conversational speech. But that was a mistake, because the speech pathologist creates a written script, and they're looking for deficits, and so they give you a written script that has challenges in it, CHs and SHs and things like that. But the brain function and how we read something is much different than how we speak. It's a different area of the brain. And so we were trying to build models that were going to mimic the area of the brain that was conversational, and we gave them a script using a different part of the brain. And so there were all kinds of paragraphs in the first 20 years that were absolutes. If you didn't have them in your paper and in your study, you didn't get published. We discovered that early on, and just because of my personality, we abandoned it totally. We don't use structured or read speech in anything we do. For speech pathologists, it's excellent. For people trying to build algorithms to identify conversational problems, behavioral problems, or other problems, it's counterproductive totally. And so for many, many years, that was a problem. Even our most recent published paper with Harvard, one of the examiners objected to the fact that we did not use structured read speech. And I would think the world's not flat anymore, How are you still there?
Yeah.
But they are. They are. And that created a barrier to progress. So going back 9 years ago, when we told people what we were doing, it was a disbelief, because there had been, quite frankly, so many failures. And then 5 years ago, we would explain to a group and show them what we were doing. And then there was more of an acceptance, but still it was a combination of an aha moment with a are you sure moment. During the last 3 years, we've gotten past that. We're rolling out.
Because of AI? Or what role did AI play in that?
I think AI played a big role. Open AI and the Nuance original product was using human transcription. So you would do an NLP on it, which got you to about 88% accuracy. Then they would send it off to India overnight, and human individuals would review it and get it to 98% accuracy and return it. And that would become the transcription. OpenAI got us to 99% accuracy, and you could train the models to be that on a routine basis. And billions and hundreds of billions of dollars was put into that by Microsoft and by everybody you can imagine. All the big players put it in. NVIDIA created chips that could process things fast. So you could look at billions of transactions within milliseconds, and that advanced the field. So as the accuracy of artificially created non-human interaction transcription became a reality, people gave more credence or credibility to what a Canary Speech type of technology was doing. We're today rolling out with the Dragon Copilot. We're an fully integrated product with them. They're listening to the doctor-patient, transcribing patient and doctor notes. We're listening to the exact same audio, and in real time, we're telling them about behavioral health and cognitive health. And during the pandemic, the AMA and the FDA in America agreed to assign certain insurance codes for audio assessment. And so when Canary Speech does this, not only are we giving them actionable information as a clinical decision support tool, but they're also reimbursed by the insurance and Medicaid and Medicare. So they without changing the time they're with the patient. So, which is so critical. Ambient listening gave us that. Real-time streaming gave us that. Those things 5 years ago were non-existent.
Yeah.
So Canary was able to take advantage of the advancement in the computational speeds to do real-time streaming, do real-time feature extraction and score creation, and return that in milliseconds. And to do that while we were listening to each other. So it becomes, here's the space of time a doctor-patient are talking. We don't interfere with that. We just listen to that. And it's non-intrusive. So of those things kind of came together to make this a practical tool. And today it's deploying in hospitals. We're adding new hospitals every other week. Every other day. So
can you tell me a little bit more about how and when is this used? So is it used when there's a suspicion that somebody has a particular disease, or when a patient shows up with certain problems, and then the doctor also turns on Canary Speech to analyze the already existing discussion? And the reason I'm asking that is because, when you've got genetic testing, for example, there's sometimes ethical dilemmas. What do you do if you discover something that you weren't looking for? And generally speaking, the interpreters will only share what was ordered. So if the doctor wanted to confirm something through the genetic test, that's what the result is going to tell them. They're not going to learn about everything else that you could possibly learn from that genetic test. So similarly, here I'm just wondering, is it done as a preventative or proactive care approach, where you're trying to find something out even if you weren't looking for it? Or is it done simply as a diagnostic tool after the person already presents specific challenges?
The question you asked, you and I could spend a week talking about.
Yeah, we're definitely, I'm going to run out of time.
But it's so fundamental and core and so important. When you're doing genetic testing, as you're aware, if I have an allele for green eyes, which I do, and a person in another country, in another part of the world, had the same set of genetic alleles, they're going to have green eyes. However, not all genetics and not all not all coding is that straightforward, and so you may have the genes for breast cancer, but you don't have breast cancer at the moment, and you may in fact never develop breast cancer. So genetic information, while the most dense and the most complex about who we are as a human being, is not absolute in all cases, as you're aware. And so early onset Alzheimer's is an example of that too. There's a gene for early onset Alzheimer's, but it doesn't say you're going to get it on, April the 3rd of your 35th birthday. We just don't know. And so in the case of what Canary Speech is doing, we're making an assessment, again, of what the individual is presenting as at the moment. Now they may be in for, we're deploying in primary care. Primarily, we develop in the specialty area and we deploy in primary care. I'll give you 2 examples. If a person's coming in for their annual checkup, they would normally do a GAD-7 and a PHQ-9, which are the anxiety and the depression question sets. They're subjective. They take the person time. They have to go do it, and it takes them less than 15 minutes to do those things. But they're subjective, and the doctor may or may not see that information before they're meeting with the patient. It just depends on the flow of information in the healthcare system. In our case, we're doing a counterpart to that, an anxiety and a depression test, but we're presenting that to the doctor. Wow. And it's objective information, not subjective. It's not a self-assessment. It's how the central nervous system is indicating our anxiety and depression levels. A real-time example of that, Kentucky Baptist has deployed our product. Others have too, but Kentucky Baptist has deployed our product. A doctor is meeting with a young mother 6 weeks after her birth. The mother is being very much like every mother on the planet Earth is often, focused on her child, focused on the responsibility of caring for that child, feeling that obligation, a good one, and a responsibility to do so. The doctor says to her, "How are you doing?" Her focus is all over here. And she says, "I'm doing fine." Canary Speech's assessment came back at virtually the same time and said her depression levels were clinically as high as they could get. So the doctor said, "Why don't we explore that a little bit more?" And by the time they had a few more questions in, the woman related how deeply depressed she was and really suffering, but her obligation was to care for the child. That's my focus. Mm-hmm. Well, that allowed the doctor didn't refer her to a psychiatrist. He's been with her for years. He said, "Let's manage this. Let's deal with this, because one of the most important things to your child care is your care." So that gave him a chance to do that. Now, could a person come in for an exam? Let's say they were a 82-year-old woman or a 68-year-old man or whoever it is. We have a number of hospitals that are measuring for cognitive health. That's a difficult thing for someone to understand for the very first time, that they have mild cognitive impairment. They're on course to potentially having Alzheimer's disease. But in an informed consent and an understanding that Canary Speech is part of this, knowing that that's there, opportunistically knowing that this person at this moment is demonstrating early stage cognitive decline, now gives both the doctor and that patient the opportunity to proactively deal with that, which is going to improve outcomes for that patient. It just will. Mm-hmm. There are no current cures for it, but I can tell you, with the pharma companies that we're working with, I honestly believe for the first time in 25 years, we will in fact have a cure for Alzheimer's in the next 2. Mm-hmm. There is some real promise. The way we pursued it previously, dealing with amyloid plaque and tau proteins and deposits on neurons, being able to scrub the neurons of those things with chemicals, proved to not be an effective way to treat Alzheimer's, nor did it improve anybody's cognitive health, not thus far. We do have some drugs that can help manage MCI, mild cognitive impairment. So knowing a person has it can help manage it and delay its progression. But an actual cure, and I'm a Tigger. If you think of Winnie the Pooh's, I'm definitely a Tigger. So I'm an optimist at heart. But some of the work that's being done by some of the pharma companies that we're working with, I can tell you, I believe we will have a cure for Alzheimer's in the next couple of years. So in that case, you'd want to know when MCI existed. Just like with Huntington's disease, we can identify early stage presence of Huntington's, which we're doing with the Harvard group. We do that 98% accurately. Are there false positives? Well, in that particular case, the false positives are pretty small. I mean, less than 1%. So,
Mm-hmm.
or false negatives, and that's a dominant gene. So we're just measuring when a person actually are showing the symptoms for Huntington's. And there
Mm-hmm.
are protocols for treatment. The earlier you start it, the better it is for the patient. So that's the kind of mode in which we're in. The primary care mode, generally speaking, as a screening tool, as a clinical decision support, providing more actionable or objective information to a clinical team. And then they
Mm-hmm.
take a myriad of other pieces of information and they put that pieces of information together to allow them to make a clinical diagnosis, which is their job.
Absolutely. Yeah, there's definitely the need to approach the treatment and diagnosis of, say, Alzheimer's disease differently, because if you just look at amyloid plaques and the imaging techniques in order to see that, I was quite surprised recently in one of the previous episodes when I spoke to Dr. Dodik around this, that at the age of 85, the prevalence of biological Alzheimer's disease is 3 times as high as actually the clinical dementia. So if you've got, so in 1/3 of the patients that are going to have amyloid plaques, only 1/3 are actually going to have clinical issues that will be manifested as a problem, basically. So for sure, a lot of need to approach these things differently. Okay, so when it comes to embedding this technology in the existing ambient technology, that's one scenario. And as you mentioned yourself, plenty of potential benefits. Faster diagnosis, shorter timelines to get to diagnosis. You don't need to go to a neurologist because you can already sense this or detect this while visiting a GP. But what about the use of technology for other purposes? So you also have this technology that's marketed for wellness purposes. So employers can basically use the technology to screen for mood states, detecting stress and burnout. Can you tell me a little bit more about how that is done? How is that used? How does that help employers? I'm just wondering, to which extent would people be against that type of screening, or would feel like that's a bit too big of an intrusion into their mental health?
Mm. So it's interesting. We have a number of organizations we're working with where they take seriously, the companies take seriously the health and wellness of their employees, providing health care, and sometimes internalizing it, where the healthcare services are provided and available to the employees directly, because there's clinics within the network of the businesses, in these cases. We are working, we're capable of capturing information in the wellness side. We have a wellness score that's based on, mood and stress, the counterparts to anxiety and depression, mood and stress and fatigue, energy levels. In fact, we think of it as the Winnie the Pooh model, the energy levels, because there is Eeyore on one end of the Winnie the Pooh characters and the Tigger on the other end of the Winnie the Pooh characters. And so we're measuring, the speed of speech, the tonality of speech, the changes in that over time. And we can do that in milliseconds of time across a conversation that a person's having, plus the tempo and the power of speech, all related to things like fatigue and kind of energy level. And longitudinally, this goes back to measuring people longitudinally. Individuals track across their life, when they're tired, they're not so energetic. When they've taken a trip from Asia back to the US, which I've done too many times in my life, it takes me a few days to recover, particularly at my age. The consequences are we're able to measure those, but we're also able to take that measurement in a discreetly unique way with the individual And then with their permission and the company's cooperation, we're able to take the entire population and from a de-identified way, create a picture of how people are doing across the entire company. And we can do that in real time. And we could do that in a dashboard for them. So they could look at their company's health. Sometimes these are healthcare institutions, sometimes they're industrial. They're oil fields in a foreign country, if you will. And under those circumstances, these remote individuals have clinical services that they're trying to access. And so they could take responsibility in their own health. They notice that a range of different health conditions are declining, and they elect to get clinical help for that. So often, information is so important. Without information, it's difficult for us to take actions in our own lives. But if we have information, then we have the ability to decide we will. Now, some organizations are doing that. It's very seldom that we're measuring, like within a hospital environment, we're measuring patients all the time. It's very seldom that we're also measuring the clinical team directly. But we might be measuring the entire nursing staff or the entire ER department or whatever, giving the hospital an understanding of the health by department, but not by individual. So that allows the hospital to be proactive in the programs it has and the services it's providing, and to help target those services to be preventive. So helping to reduce burnout, helping to improve the overall health of their employees. These are areas where we're very sensitive. Canary's very sensitive. Employers are very sensitive, and individuals are very sensitive to confidentiality, to not having information used in the wrong way. So Canary Speech only deploys under a high trust, data secure environment, AI for good. We're audited for all those things. Not only that goes from how we develop things to how we deploy things, the whole spectrum. And that was something decided in the bagel shop 9 years ago. Because just like yourself, we're asking those questions. Whenever you have something that can be used for good, it's like the double-edged sword. The greater its potential for good, the greater its risk for bad.
Yeah.
It just is. And the wonderful thing about the healthcare industry, and we need to adopt some of these principles into cross-industry. In the healthcare industry, we've been planning that and creating structures for the last 40 plus years to watch for the efficacy and integrity of individuals. When you go into other industries, we need to adopt similar programs and similar principles. Canary is started in clinical. We don't develop anything outside of clinical. And then we go cross-industry from where we developed it in clinical, where all the hurdles, all the requirements, all the expectations are higher. So that's where we develop. And if we're going to deploy it out here, we already have the infrastructure in place to say, here's how you do AI for good, in our opinion. We won't engage in it unless there is a legitimate set of guardrails.
Okay. What are the technical requirements for voice capture? Is there a quality requirement for you to do an analysis? The reason I'm asking that is especially for remote patient monitoring. What kind of devices are used in those scenarios, for example, especially in clinical trials? Can you elaborate on that a little bit more? Is it patient devices? Is it devices that the researchers doing clinical trials provide? How does that work? And what is usually measured when your technology is used in clinical trials?
So we can capture audio across numerous different devices. Smart devices actually have pretty good microphones in them. Smartphones, tablets, video conferencing, even telephone systems. They're all different. We're teamed up with Samsung and we can use the Samsung Watch as a capturing device. We're actually coming out with a wellness model that is enhanced by the other information that the Samsung Watch collects. We call it Canary AI Wellness. So it's enhanced by AI because we're looking at sleep time and walks and steps and heart rate and other things, all captured by the Samsung Watch on the wrist, becomes part of the algorithm when we're looking at mood and stress or anxiety and depression. So all of those different audio capture devices are slightly different. Again, 9 years. We test them all, we validate them all. And then we have incorporated into our API, which is, let's think of it as the tube through which the data is flowing. We've incorporated quality checks. So we know what the signal to noise is of the audio we're capturing. So we evaluate not only the audio stream that we're getting, but the quality of the audio stream we're getting in real time. So if the audio stream doesn't meet certain levels of quality, then we simply give a notice back that a new audio has to be obtained in order for us to process it properly. Because, and Canary is taking advantage of advanced new technology. And we're not only on the cutting edge of what we do, we're on the cutting edge of technologies that are available to do it. And one of them is the ability to have AI enhanced capabilities as we're capturing information, or as audio is streaming to us, we're evaluating the actual signal to noise and the quality of that audio in order to do a proper evaluation. So if you're getting bad data, you're going to get bad results. In the past, you needed human intervention to know that. Today, just like with OpenAI, improving the textual quality of transcription, those same types of tools are available for Canary Speech to evaluate those types of things in real time. You just have to deploy them. You have to understand how to integrate them into your systems. So that's what we have done. The primary way, and I haven't spoken about one other way we deploy, we can actually take our developed algorithm and we can put it on an intelligent device running on a NVIDIA chip. So that means within the 4 boxes of a hospital, if they're doing an AI, like a room monitoring system, has a patient fallen out of bed, is compliance, are they up, are they moving, have they turned, all kinds of intelligence in a patient's room. Canary Speech is part of those programs now. Mm-hmm. And we look at the things we're talking about, but we're also looking at levels of aggression in a patient's room. So is a family member angry about the treatment their patient is getting? In America today, nurses are attacked multiple times a day. 20% of first-year nurses left nursing because they were attacked by a patient or a patient family member. So Canary Speech is deploying with healthcare to help identify those situations, to be able to proactively work on that. We create a green, yellow, red light warning. We can measure up to 5 individuals' aggression levels. We don't specifically measure aggression in an individual, we measure it in the room. Mm-hmm. So that means we can proactively deal with that. So Canary can deploy across all those spaces, but the only way you can do that ethically, with ethics, sorry.
Yeah,
the only way you can do is to test it, to qualify it, to validate it. So if you're in healthcare, that's just a requirement. You can't enter a new feature or capability without doing that. I mean, and so that's how Canary just tries to run it. We don't even try to run it that way. We run our business that way.
We have like 5 hours of interesting topics to cover for sure. But I do. It's if you do that, say you detect a high level of aggression in a specific room, what does hospital do? It's not just about an individual. It's basically about changing the whole workflows. Like, do you add security guards to the hospital? Like, what? There's a lot of changes that these types of insights can kind of introduce.
So currently what they do is these systems try to identify try to identify words that would indicate that aggression levels. Someone is yelling certain words. They try to identify word-based. And word-based can be accurate or it can be completely inaccurate. It's just not a very good way of doing it. Nurses currently have like a safety word or something where if they're in a room and they're in trouble, they're saying a certain word, which would call. So they already have protocols in place to help deal with this. In the U.S., the alarming number of individuals, 20% of nurses left nursing. They didn't leave the hospital. They left nursing entirely last year. $20 billion of cost to the institutions. I mean, that's coming right out of providing care, So dealing with this is a high priority. What we do is if a person sees a yellow or a red light, they don't go in the room alone. They go in with an understanding that there could be a situation, and they go in to de-escalate the situation. Rather than get into a situation where they're being attacked and they're yelling a safety word. Because by the time they're being attacked, the safety word just means someone is down the hallway and you're hoping they get there in time.
Yeah.
In this case, you're more proactive in this situation. It's intelligence. It's actionable information. The processes are already in place to communicate those kind of things. So Canary Speech is just fitting into those processes, but providing proactively information ahead of time so that you can de-escalate it rather than enter the situation, have a negative situation occurring and trying to stop it. Go in to de-escalate a situation that had not yet started without pointing the finger at a specific individual, just understanding that there's discontent in the room. I'm going in to help deal with the discontent, which is what we all want to do. In any situation, people get upset or angry because they're disconnected from maybe what they believe the care should be and the information they need to understand that, in fact, it is. So you're providing a heads up, if you will, or a proactive way of dealing with that. Okay.
What about remote monitoring and clinical trials? So what are the use cases there? Is it just for the conditions that we were mentioning before, so Alzheimer's, dementia, Parkinson's, mental health, or is remote monitoring or clinical trials and the technology combined to detect something else?
So let me mention up front, we're currently developing 17 additional disease states. So we're adding to all of that. Things like
What kind?
well, PTSD and postpartum depression, ADHD and autism for children. We're adding, we have a pain model that will roll out shortly. So we could actually measure pain instead of tell me where it is on 1 to 10. We actually measure it with vocal biomarkers. And then we're expanding in the languages, validating in new languages and things like that. COPD, those types of things. So in the pharma sector, we're providing a front-end tool that if they're trying to identify people to participate, let's say in a cognitive study, and they want to know that either they have or don't have MCI, we're very accurate in telling them over the telephone when they're doing their initial interviews that this is an individual that's not demonstrating MCI. Now, they'll do further evaluations of them, but if I'm looking for a group that doesn't have MCI and I'm looking for a group that has early stage MCI, Canary can be very accurate in a very quick screening to kind of identify a pool of individuals inexpensively and very quickly. When you get to look at if I have an Alzheimer's patient and I'm hoping that the therapeutics that I'm using help move them over a period of 6 months towards better cognitive health, are they moving to MCI levels of cognitive performance, or are they in fact moving to a normal level of performance? And Canary Speech can measure the difference between that gradient. So we're capable of measuring that kind of thing. Same thing is true for things like anxiety and depression if you want to do an anxiety study for a new therapeutic to deal with anxiety or depression, and you want a control group that demonstrates certain levels of anxiety and depression to be part of your study, we can qualify individuals over the phone, and then they would have further tests and studies with them, but we could help qualify them. And then we could track the effectiveness of that therapeutic throughout the study period.
Mm-hmm. Sounds like quite a revolution for mental health treatment development.
It could be. And, you know, for years, we were developing MCI and Alzheimer's drugs, which could demonstrate that they were removing amyloid plaque. And in fact, there were new drugs in the marketplace that were removed because over a period of a year, they didn't demonstrate that they actually improve cognitive. And you mentioned this earlier. They didn't effectively improve cognitive health. They were very, very good at removing amyloid plaque, but not effective at improving the outcome for the patient's cognitive function. So if you're measuring cognitive function rather than just chemically demonstrating or from images demonstrating that amyloid plaque has been removed, you have a broader array of information upon which to judge the efficacy, performance, and effectiveness of a therapeutic.
We are running out of time, so there's just one more thing that I will ask before we wrap up, and that is, given the development that has already been in place, where do you expect the technology to end in the upcoming years? And secondly, given that you mentioned that, you know, from the get-go, you were working with a diverse team of experts from across the world, how widespread are you on the global market, given that obviously the US market as such is already a huge market from the business perspective to undertake, but the need for what you're addressing is huge globally.
So going back about 18 months, we were in a position where we felt we could begin deploying. You know, we had ambient listening capabilities, and we were working with a number of different teams, Microsoft, Samsung. We're working with United Healthcare, Optum, and Cigna, looking at deployment in multiple hospitals across the U.S. But we're also deploying in Japan. We're deploying in Canada. We're deploying I mentioned Holland earlier, also in the United Kingdom and Ireland. So we're beginning to see traction in all of those places. South America, for instance, is growing tremendously. I was in Ibiza at the Alzheimer's Association meeting recently, about a month ago, where we presented with a team from Guatemala. You know, so 4 years ago, if anyone said, "Oh, you'll be working with the team in Guatemala," connection at all with them. Today we do. We're testing, we're rolling out in 6 different nations in South America in Alzheimer's disease. We're rolling out with a number of other groups there. So South America, US, Canada, Japan and Saudi Arabia are probably, the Arab countries are probably the ones adopting fastest. And then we're working in Holland and we're working in other places. We'll roll out in German later this year, or early next year. We're adding German, for instance. And so once we validate in a particular language, we're deployed in these places already, but we're then commercially available to do something. I mean, once it takes some time to validate in each of the languages in order to deploy. English languages, Spanish, Dutch, we're adding Mandarin. Mandarin will be done by the end of first quarter. And for U.S. Mandarin or Chinese populations, Mandarin speaking people, for about 4 different diseases. So that's kind of the rollout. We have demoed our product and are rolling out to more than 1,000 hospital clients in the U.S. right now, in our partnership with Microsoft, for instance. But also, go ahead.
Can or could or will patients be able to get and use this technology just as consumers anytime?
So we are going to introduce a consumer-based product this year. We're
In 2026 or in
yes,
2025? 2026.
2026. We're piloting it right now. Everything that we do is based on the clinical models, which is different than many other companies. Many companies have developed using Facebook or Craigslist as data gathering sources, which we just would never do. You can't control for that. I don't believe it's ethical to do it that way. You really need a controlled clinical environment to properly build the models. That's just our opinion. So we're going to pursue that line. But we're rolling out a wellness product first to industry, where industry would use it with their employees. We don't deploy, we do have an app. We use our app internationally across multiple countries, across multiple languages, but we don't deploy or sell an app. It's not something we do. There are a number of healthcare institutions using our app configured for them, specifically white labeled, if you will, to them. The reason we didn't was this focus on an intention that you needed to develop over in the clinical space in order to get the efficacy and get the requirements and get the review, peer review and papering, academic papers. So that's kind of how we did the work. It's a little slower, it's a little more arduous, it takes a little more time, but I personally think it's well worth it. So now we're going in 2026, we will be rolling out to a wellness version of this. And so that we will see advertising for it in first quarter, launch of it in first quarter. All of it based on the clinical models that we built over here over the last 9 years almost. Okay.
Yeah. With the aging population and also the impact on brain and memory that we're starting to unveil with the research of information overload due to social media and the technology that we use, and the fact that we're online for too long every day. These technologies are definitely increasingly important. So I definitely look forward to seeing how you are going to evolve. But today, Henry, thank you so much for your time and the extensive explanation of how the technology has been developed and what we can expect in the future.
Well, it was a delight. Thank you.